welcome to take the stage, Christopher.
Thank you, Jack. Nice to see so many people wanting to hear about this project that we have been a part of. I'm just going to share my screen, hopefully get the presentation up. As Jack mentioned, I am representing Raccoon and has been a part of this for during the whole project. And I'm just going to start to say a little bit about Raccoon, our products and what we do and what we have been aiming for in this, so that you have a background before Abhilash is talking about the technical perspective. Just a moment. So, okay, about Raccoon, it was an idea born in the early 90s, actually from Olle Sydlén, and as you can see, we share the same last name. So this is a family-run business in Robertsfors. But he was in a fair in the early 90s, visiting the Ferrari and Williams Formula One team to see how they were working with quality control in the engine, I would say. But when he was seeing how they were working with the engine filters and how important every step was, he was quite interested to see if this is something that can be done or taking part of to see how it would be like an air filter. And since he was quite interested in heavy equipment, it was more like doing some cabin air filter in some sort of same way. So he started to do some testing in our garage, actually, during a period of 6 years. And he was looking globally about what kind of filter media was able to do to meet the standards of the ID he had. And eventually he found one that was quite good, but the real breakthrough he had during a night when he woke up and took our microwave oven from the kitchen till the garage and tested it. So that's when he had an idea, and of course it's been much perfected during the years. That was just the start to see some initial results. And then Raccoon actually was it was the starting point of Raccoon. So it started in the 98 actually. So about our manufacturing process, we have a factory, as Jack told us, here at Robertsfors, where we do everything. We cut the media today, we process this in this like microwave technique that we have. We also do the frames, and so we assemble it all here to be a ready air filter. And when it's ready, we have this combined particle and gas filter, which is our unique selling point, that you have that combined. And since we are working with heavy equipment heavy equipment that goes in the harsh environments like mining and forestry, which is our big markets, then it's really a really good choice, since otherwise you have to either choose a particle filtration or a gas filtration. So our aftermarket product is a combined particle and gas filter, which suits very good for example, mining, where you have ammonia or other gases as well. So depending also what kind of concentration of gases, we also have different levels of the product itself. So you can have, if the concentration is rather low, it just suits with one filter, but if it's high, you need to choose another one. But it fits right in the box. That's you just change your original filter to put this one in. And so the heavy equipment, just to some of the markets, so we have mining, as I said, and forestry, which also has their problems, and the decontamination, depending on what it is. You need to make some special filters sometimes. And we also have waste or energy plants that we work a lot with. So we are globally, but we are most working here in the Nordic countries. And of course, we have done some special work as well. So it's just not like in these heavy equipments, but this is the most common for raccoon. And for us, since the start, of course, health and safety is the main focus for us. I mean, we're choosing the right media and the right process to have health and safety. Our product must deliver that capabilities, so you're safe in the cab. But we are also looking at the environmental impact we're done, and to see how our carbon footprint are been during the years and trying to reduce it. So even if we are always looking at health and safety as the main focus, we're also looking at the environment. That we're doing in different steps. We of course are looking how much media, how much materials during this process is waste, and how can we use that waste in some other way. We are weighing it, we're measuring the impact. We are also have the solar energy using this factory, so we're trying to lower that during the time. So we have been on this through many years. So this is something we are looking for. We're also in our product, I mean the media itself, or the frame, or something else like packaging and transportation as well. So during this, when we got in contact with RISE in the late of 2021, we had some really interesting talks about replacing the filter media that we use today. I mean, it's plastic, polymer, and is it possible to do something more sustainable that fits in our process so we can still achieve this protection so we can deliver the high quality product that we do today. And of course, there was some really interesting talks. I mean, me and Olle was kind of fired up from Abhilash and Peter and Jack, who was in this project initially, talking about what we could look at. But of course, I will leave all these the technical presentation to Abhilash, so you can question him about that. So I think that was a really short presentation for us. But if you have any questions during the time Abhilash is putting up his presentation, just go ahead.
Can you see my screen?
Yes, looks great.
I'm trying to move this. Yeah, okay. So, thank you, Christopher, for the introduction. So, at around the same time as Christopher and Ole were exploring options for more sustainable filter media, we at RISE were also considering air filtration and bio-based materials, and we reached out internally within RISE, and we had a person who was responsible for connecting with various SMEs, high-tech SMEs, and similar to Raccoon. So he was like a matchmaker. So we connected and we started discussing. And basically the needs from Raccoon was very clear, and that always helps for us as RISE to support the industry if it's very clear what we need. So just to sum it up, today, at least in some of their products, they use polymers basically, and different types of polymers, and they wanted to explore more bio-based materials as the starting material. They of course have some value-added steps, specific coatings and specific post-coating processes, so we will not touch that, but the point is that the base material that they use, could we replace it with more sustainable alternatives? So this was the problem. And of course, to do anything, we also need funding. So we explored different options, and together we came up with this Vinova program for bioinnovation, it's called. And they have multi-step project proposals that they fund. So we decided to start from the very beginning, the step one, which is meant for testing hypotheses. So we had a lot of internal discussions about who should be in the project team, what should be the hypotheses to be tested, because we have to be very focused and clear on what we want to do in this step. So we reached out to some potential companies who eventually became partner later. And then finally we decided that it's just raccoon and rice would be a good starting point to explore different options. And we formulated the hypothesis as such that can we make biomass into foams similar to what raccoon uses today? And can these foamed material be used as an air filter? So it was a very a basic hypothesis testing type of project. And we actually got the funding, which was very nice. That always helps. So with that, we started discussing internally and also within our collaboration network in general on what are the different options we can start with. And finally, we came upon regenerated cellulose fibers or cellulosic material as a starting point. And this was just an example starting point and not necessarily the final material. Because our point was to test if we can make foams out of such materials. So we actually explored a few different slurry formulations, foaming agents, and people working in the foam field will know that also the drying and dewatering conditions are very crucial. So we had to kind of figure these things out in a lab scale for ourselves. And then finally, we could actually obtain centimeter sized foamed materials, basically. And the final configuration was regenerated cellulose material together with a brewery spent grain, which is also it's a common byproduct in breweries, basically. And this was used as a filler. So with this combination, we could get a foamy material, and then Raccoon has a coating process and a post-coating treatment step. So we also had to make sure that the foam is compatible with that. So the surface chemistry is compatible with the coating. So which required hydrophobization. So we also did that as a post-foaming step, basically. We hydrophobized the material, which we can see from this water droplet, and then sent small samples to Raccoon where they could test out their coating method. So I'm trying to summarize like a 6-month project with one slide. So I'm of course moving very fast, but if you have any questions, we can take it up later. So having made and sent, so the material part being done, we also had to, and of course we did some preliminary characterization as well, some imaging, both at electron microscopy and also some regular microscopy. And we can see that we have a nice foamy, porous material that in principle could work as a filter, basically. So we went ahead and did some rather basic evaluation or comparison, basically. So we compared the original polymer foam with our foam, and we could see that in terms of mechanical properties, airflow properties, density, they were comparable. And not exactly the same, but they were comparable. So confident with that, we also wanted to test it out in rather realistic operating conditions as well. So Raccoon actually rigged up one of their filter cartridge with a small hole to fit this small piece that we made. And they inserted that into the filter, the slot for the machine for air filters, and tested it in realistic airflow conditions. And using Christopher's words, it didn't break apart. So basically it survived. So in principle, it can be, it checked all the boxes at a very preliminary scale, at least, that it can be used as a filter. So we call that as a hypothesis tested, and that it does work. But of course, a lot more work was needed. So with that intention, we went to the same funding call, and then they have a step 2 proposal that we can send in also for a more in-depth testing of the hypothesis. So it's still a hypothesis testing, but in a bit more in-depth manner, basically. So then again, a lot of discussions, and this time we reached out to our collaboration network, including the companies and partners that provided us material for doing this step 1 project. So there we started discussing with Miguel from ShareTex, and also our brewery partner who gave us some of their spent grain. They decided to join in as a partner, and that was Oppigard's Brewery. So, and then of course we also needed some partners to help scale things up, because centimeter scale materials won't really help. So a daughter company of Rice called More Research also joined in, Sarah from More. So with a larger team and with a clearer set of goals to move up the technology readiness level, and also the manufacturing readiness level and sustainability readiness level. And I'm using these terms because these are required in the funding call to define, at least to have a clear objectives on where we stand in terms of the readiness level of the technology. So we set some goals for the project, which was that instead of doing a rigged up filtration test, we should be able to do it in a high fidelity manner. So it should be like the foam material should directly be inserted into the filter material, into the filter slot, not having to make any special adaptations for it. And of course, we should be able to make the material reproducibly in a larger size as required by the customer. So these were the goals. And of course, we had to secure the supply chain. So we will actually use the real materials provided by our material partners and proceed with the processes and make a final filter or a set of filters that can be directly used without having to modify any existing parts. So with those goals and with a larger budget as well, we started. And again, summing up almost a year's worth of work in one slide. But let me try to do that. This gray plastic bag with the gray stuff in it is actually post-consumer viscose textile. So I could probably, this is a good time to say that when we were setting goals, we also wanted to set the raw materials and the feedstock and choose it appropriately. And this was the point when we were introduced, thankfully, by Miguel. We are very happy with that and having him on board, basically. The immensity of the problem of post-consumer textiles. So we have millions of tons of post-consumer textiles waste available. And if we now look at it in a different lens as a feedstock or a raw material, then it's actually fantastic news for us, because we have plenty of that material available. So this gray stuff is basically uncolored, non-color sorted. So basically random mix of colors, but actual viscose textile that has been processed by ShareTex. And then this is a waste material from that. So a pulp made out of it, basically. And then we used our the basic process. Of course, we had to adapt it a little bit with different binders, again, bio-based binders and hydrophobizing agents and everything, but we could replicate the process that we developed in the step 1 to make small scale centimeter sized foams in our labs. And then of course we together with more research, we could scale it up to the larger sizes, in fact exactly the sizes required by Raccoon. And here we can see when we handed over the one example foam to Christopher, and you can't see his face here, but he was very happy to look to actually see it a much larger piece of what we could make, basically. And then they proceeded and used their current process to insert it into their filter cartridge, and then insert it into the machine and test it out under realistic conditions, basically. And one point to mention here, probably is a good time to mention, that it looks gray at this point because the textiles that was used by Miguel was not sorted by color, basically, and they did not bleach it. So all colors mixed together is like a shades of gray or black. And it is rather possible to selectively pick up only colored textile, single color textile, for example, red or green or blue or something, if available, of course. And then the filter will be basically following the color. So we don't have to do anything extra to color the filter, basically. So that is also, it is probably an advantage to continue to use the colors of the textile to keep value in the future as well. So we basically, coming back to the main topic, the filters, again, they were mechanically strong. It survived a realistic airflow through it. And they also tested under a few different environmental conditions of humidity, I think, or spraying with water. So overall, of course, it's not ready at this point to be used in out in the rain or snow, but it was surviving, basically. And then we actually also, during this project, we discussed with our partners and also within our larger collaboration network, and we learned that it's not just viscose, but there are other textile blends that are also problematic in terms of recycling. There are several technologies out there, but still not all textile blends are ready for it. So we tested a few of those very quickly, very short tests, basically. So we actually went to a shopping mall, bought some of those textiles, and then together with the textile recycling part of RISE, Stina was very helpful in that step, a lot of discussions with her. We actually turned this into a raw material. So she did all the processing and the pre-processing part. And then we could actually use our process just quickly to test if our process can work with other textile blends as well. And we were very confident with our outcome. We could make foamed materials as well as we could make rather flat and more dense filter material as well. We did not test these, of course, because our project was focused on the viscose, which was the main issue. So then with the part of RISE that does air filtration tests, Christian Mosberry, a lot of discussions with him to design the test, basically. And then this is an example of the test setup that he has. So we actually made the filter media, 6 replicates of them, so that we could use this setup. And then he tested the actual particle separation efficiency. So I must emphasize at this point that we were not focused on optimizing the particle separation efficiency at this point of time. Our main focus was to scale up and produce reproducibly or replicates of at least 6 foams of the size that they needed. So that was the main focus. So I would say that this was like trial 1 of the material. Even in that, we, of course, to be realistic, with the size of the diameter of the fibers and the density that we have, we were not expecting to trap nanoparticles with our filters. We were not expecting to make HEPA filters. So as expected, the efficiency for PM1 was quite low. But the PM2.5 was actually, it didn't pass the test, but I would say it was still decent for the first trial. And when it comes to PM10, which is capturing 10 micron particles, up to 10 micron particles, it actually passed the test. I mean, the test, I think the ISO test requires it to be at least 50%, and it was close to 70%. Just to be clear, we did not actually do a proper ISO test. It was a test, and the calculations were identical to the requirements of the ISO test. So I would say this is an indicative result of the actual ISO test. Nevertheless, so we have like, so with PM10, we can already use the material that we have as a pre-filter or for ventilations, or even for Raccoon's machines, for example. So it's actually working. So this is more like a more high fidelity TRL6 type of result, I would say. And of course, more work is needed to improve the PM2.5 efficiency to capture up to 2.5 micron particles, the finer particles, basically. And then we need to basically raise the efficiency in this part of the curve. And it's not impossible to think that it should be doable to some extent, in the sense that if we just adjust the foaming conditions to make smaller bubbles and smaller cell sizes, then we can actually improve the efficiency in this micron size particles range as well. So that is the expectation. So in our future work, this is what we should aim for, basically, to make it work not just as a pre-filter, but as a main filter, basically. So if we want to think of where we stand today, and I have this because this is a requirement from the funding agency to show the movement in terms of market readiness level, technology readiness level, and sustainability readiness level. So compared to the start, we have moved quite high up. We actually showed, I would say presumably TRL6, the technology that it can be used as a filter. The sustainability readiness level has also moved quite high because initially we were focused on biomass as a filter media rather than the polymers and glass fibers. But then now we have selected a particular biomass, rather a particular feedstock that is very relevant in terms of sustainability, which is namely the post-consumer textiles. So we have moved quite far in sustainability readiness level also. Within this project, this is what we could reach. To move the sustainability readiness level further, one would have to do a proper analysis of it. And that is definitely an interesting topic in a potential next project. And of course, the market readiness level. So we have actually used more facilities for the final large sized foams, and they have quite a bit of knowledge, and also they are building up infrastructure for a continuous production. It's probably not ready yet, but very soon to be ready. So we can rather quickly move up in the manufacture, the market readiness level as well. But this is where we stand today, basically. And just to have an outlook, an overall outlook of the situation, if we focus on viscose or man-made cellulose fiber, textiles made out of those, then we have millions of tons generated annually as post-consumer waste. And that's a huge amount, to be honest. And these are also the fastest growing fashion textile in the industry. So the millions of tons will only grow in the future to be more in terms of amount to be handled, basically. And among all the textile blends, this is one of those textile blends that does not have a rather ready recycling technology. Just to be clear, if we are recycling textiles and then the recycled product on a per gram basis, if we can turn it into another textile, that would be the best and most valuable material. So there is no doubt about that. But still, there are several textile or fiber to fiber recycling technologies, and RISE actually is working with many of those companies, including our partner who has some technologies in this field as well. So the point here is not to compete with the textile to textile recycling, rather the fact that those are very textile blend specific, the technologies. So there are several blends that do miss out or can't be used, and then we are focusing on that. So basically we are trying to cover, together with the textile to textile recycling technologies, we are trying to cover all or maximum possible types of blends to handle all of the hundreds of millions of tons that is annually generated. If you take all of textiles together, that's really a large volume. So it's like a mountain of waste, and we need all the technology available to address and handle that, basically. So this is just to supplement the fiber to fiber technologies. And on the other hand, if you want to focus on another market segment that can handle, which is a rather high value segment and also can handle the volumes, that would be the global air purification market, because these numbers were basically when we wrote the proposal, that was like a year ago. I'm sure this has changed and definitely moved only upwards in terms of the potential market size by 2030. It's tens of billions of dollar industry. So it's a very high value market. And also there is a huge and growing demand in that. So it's almost like a match made in heaven. There is a huge supply of waste. It's so huge that it's actually a problem today. And there is a need to consume the post-consumer textiles. And on the other hand, there is a huge demand or increasing demand in air purification industry as well. And today, just like as Raccoon pointed out in the beginning, the filter media are made out of polymers or glass fibers, and there is a strong consumer demand as well as a company's push towards exploring sustainable filter media. So in all aspects, it checks out, the demand and supply works out. And also there are some regulations coming up in the horizon. So it's a good time to get into this in this track of converting post-consumer textiles into air filters, for example. So how would it look like? What would be our next step, basically? I just wanted to give an overview because this is a very important field and it's a very important track. So we just got warmed up, basically. We are still planning to take this forward and keep at it until it actually becomes a reality. So a future next project would be a full value chain project. So we want to expand our partners. So at this point, we are covering our partners that I listed in the beginning, including Raccoon and ShareTex and more. We are covering this middle part of the value chain, but we want to involve on the upstream side, more garment brands, recycling companies, for example, to be a part of our project. And on the downstream side, we want to involve more wider range of air filters, basically. So honestly, we are in touch with several key players all along this value chain. We have got very positive response in all those aspects. But of course, we are still open and we are looking for more because we want to work with all the relevant partners so that the value chain will smoothly become a supply chain in the future. So that is our objective. And if you're interested in this, then please don't hesitate to contact me or Marie-Claude. The email addresses are here. So that was pretty much my last slide. So of course, full acknowledgement to the core team of this projects, I would say, that we have been running. So it's Yerk, Petru, Sarah from More, and Foro from More. That's the RISE team. And of course, Raccoon and ShareTex and Opigord's Briggery. So this is the team, and as I mentioned before, this was just a core team. It was almost like an all of RISE collaboration already within this project, and we are now closer and closer in touch with the textile part of RISE and the air filter part of RISE as well. And also we have another sustainability part. So we also have to analyze the sustainability impact of it. So it's a all of RISE collaboration, and I would say as of now, much larger all of Sweden collaboration as well. So it was a fantastic experience to work on this project, and we completely and definitely intend to keep working at this track, basically. So that was my last slide. Thank you very much.
Thank you very much, Abhilash and Christopher as well. Now this presentation is open for discussion. So please post your questions to Christopher and Abhilash.
Can I have a question?
Yes, please go ahead.
I have a question for Abhi. In the test results, I see the EPM1 to EPM10 test results. The pressure drop is like 166 Pascal. What is the airflow or air velocity in this test, if I can ask?
I don't have it off the top of my head, but Christopher, do you remember? We tried 2 different airflows. Was it like 1?
Yeah, 1 and 0.3. I don't really remember now. But
So like centimeter per second, right? Or per minute, I don't know.
I don't really recall now.
Mm-hmm.
We tested 2 different anyway.
Like by the ISO standards.
Yeah, exactly. Yeah. Yeah.
Okay.
I think if I'm not too, I'm just making a guess now. Meters square per second. If it makes sense. Cubic meters. Yeah, cubic meters per second could be. But I will get back to you in an email.
Yeah, no problem. Thank you.
So as you can see, I mean, we are materials scientists, most of us in the core team, but this was done together with Christian Mosberry, and most of you in the air filtration business know him. And so the test was basically designed in discussions with him. And from what I understood, it is essentially replicating the ISO standard test, but not following it to the letter, but it's based on the standard test. So yeah.
I mean, if it's following the standard test, probably like the most common 2 option is like 2 and 5.3 centimeter per second, if I remember right. Yeah. Yeah. Yeah, interesting to see. Thank you.
So, Christopher, I have a question to you, which relates to the necessity sort of to be sustainable. And I know you have mentioned before in discussions that the filters in the heavy equipment, which you equip with your filters, they are exchanged quite often. Could you comment on that?
Yeah, of course, it depends on the environment itself. Since we have done testing in mining, you might need to change them every 400 hour. If you're working at a waste energy plant, you might be getting up to 800 hours. So it really depends, but it's quite often, and those heavy equipment goes around the clock. I would say 24 hours a day. So it's often, and then still a lot of these heavy equipments also use pre-filters. So often there are like 2 filters. So when we have done this project, as Abhilash has gone through the technical details, if we just can change the pre-filter, which is changed like 2 times during the lifespan of the main filter, that is a huge win in increasing the value of biomass residues, I would say. So, I mean, there's really something to gain here. And even those filters that we got results from can be used in a lot of applications. But of course, if we can get even higher than this, which we are hoping for, and aiming for, it will be more beneficial, of course. So, yes, it's a lot of filters.
Yeah, and even with these results, which are not yet have led to a final product, but is on the way, do you see any interest from your consumers in sustainable solutions?
Yeah, of course. I mean, almost all of our consumers are talking about sustainability, and they also want to see something that they can brand, like that they are doing some efforts in. So of course, even in our business, there are interest in these kind of sustainable products. So I think it's a huge win for almost everyone.
Very good. And Abhilash, since you have this slide up, you mentioned briefly that you could make smaller bubbles or cells, or there could be different ways to optimize the filtering capability. Mm-hmm. How does that work in practice? Do you have any examples?
So it's quite common knowledge that if we have I think it's called the elephant's toothpaste or something. So if you have a viscous material liquid with a lot of surfactant, and then we apply some mechanical energy, shake it up really hard, then it becomes a foam, basically. And if we have played with it as a kid or even as an adult, I sometimes do that, we can actually make the foam very high density or low density with larger or smaller bubbles by just changing the mechanical energy. So that is just a very simplistic first step, a way to look at it. There are, of course, a lot more high-tech foaming techniques where we can adapt or adjust the foam size. And we have tools also to analyze the foams, that is to study the size of the bubbles and everything. We have not done that in these step 1 and 2 projects, but that is something that we should explore in the next project, in whatever form it is, to make much smaller bubbles, for example, and then the final foam would be having much more finer cell size, and that would improve the trapping of smaller particles, basically. Mm-hmm. And and of course, as I probably mentioned before, we are working together with a scaling up or upscaling partner. So before we select any process step, we consult with them or we do it together, so that whatever we do in a lab scale can easily be replicated in the continuous or semi-continuous production lines that they have. So as soon as we prove something in the lab scale, it can be very quickly turned into a larger scale production, basically.
Very good. Are there any more questions from the audience?
I would have 2 questions. Hi.
welcome. Hi, please.
I'm Judith from Bergens. Very, very interesting presentation. Thank you very much. Filter is not my area at all, but it was super interesting. So question number one, you said you talked about the sustainability impact, which needs to be checked for sure as well. Can you tell a little bit more about the viscose pulping process and the impact here before you start doing the properties for the filter?
So in this project, we obtained the material directly from our textile recycling partner, ShareTex, and I'm sure Miguel is in the audience. So I don't want to. It was not a part of the project, the viscose pulping process. That is their product, and they have. So what they do is, because we can't use it for textile to textile recycling from starting with viscose. So this is what he told me, that they have some method of extracting chemicals out of the viscose. So this is a byproduct of that process, basically.
Thank you. And the second question is the recyclability of the used filters, because I imagine they are highly contaminated then.
So that's a very good question, actually. Let me just move to the appropriate slide, and then I can. Yeah, exactly. So so we have to actually come up with and this is exactly one of the things we discussed a lot about towards the end of the project, that the work plan for this next project has to cover all aspects, including end of life aspect as well. So obviously, a filter that has been used in a chemical laboratory or a mining shaft cannot be, it has to be handled separately according to the existing laws. We have something to look at in that case. But if it's, for example, in a building ventilation or in a regular use, like in a vacuum cleaner or something, in that case, what we are considering is that one of the things to be explored, it would be how many times can we repulp the foams that we make, basically. If we identify like maybe 5 times or 10 times until it falls apart completely and we cannot turn it into a filter, then that would be the basis of the sustainability impact, because the number of recycling that we can do is an important aspect. And if we work together with textile sorting and recycling companies, then a future product could be marked as textile waste. Although it's an air filter, it could be marked as a textile waste and discarded in the textile waste. And the sorting companies would know that, hey, this is not a cloth, it's not a t-shirt, but it is, they will know exactly what to do, whom to give in the value chain, basically. So that is the plan.
It's about transparency again, or how to communicate that you can, yeah.
Exactly, and then labeling the product appropriately, and also we have to do this analysis of what trace elements we have, at least at the first step when we pick up the post-consumer textile directly also, because it will depend on, so we have to be very careful in designing our project tasks, basically. And a lot of this information came from discussing with the textile part of RISE, Stina. I don't know if she's listening in, but thank you very much for that. So we designed a lot of discussed, and we have like a plan for what we should do in terms of investigating and making an inventory of all the trace elements and everything at start.
Perfect. Thank you very much.
Thank you for very good questions. Are there any more from the audience? Unless there are, I see no more questions at this moment, but feel free to interrupt me. Otherwise, I will slowly begin to close this session. If more questions arise, you have Abhilash's email address on the screen. You can note it down and contact him. And Christopher, I'm sure you can find him if you Google Christopher Sylén and Raccoon Miljöfilter. And as already previously said, this presentation has been recorded, and it will be a link to the video will be shared with you afterwards, so that you can revisit this. And other than that, I thank you for your participation and hope you will have a good day. This is a good way to start the working day, I think. There will be another seminar tomorrow on a similar theme, but even though quite different, it will be on a nanographite paper where Andreas Fall will be presenting his interesting research. And with that, I say thank you very much and would like to hear from you again. Goodbye.